Hello, 7th graders. Welcome to 6.4. Today we're going to talk about percents of increase and decrease. For our learning target today, I can explain the meaning of percent of change. We'll start off right away with some vocabulary and our key idea. Notice that we got some highlighted sections here, so a couple of important sections that will be important to look back at. I would give yourself a little star as a reminder to come check these out again. Starting off with the vocabulary, a percent of change is the percent that a quantity changes from the original amount. Okay, so when we're finding percent of change, we're finding out how much amount of change there was divided by the original amount. Okay, so this is a general statement that's saying anytime you're looking to find how much or what percent of a change you had in any type of situation. There's hundreds of situations that we'll work with dealing with percent of change. You just take your amount of change and you divide it by your original amount. Now, we can get a little bit more specific and we can look at, is that a percent of increase or is that a percent of decrease? Okay, so it says when the original amount increases, the percent of change is a percent of increase. That's fairly intuitive. When your amount increases, your percent is going to increase. Okay, and likewise, for when the amount decreases, your percent of change is called a percent of decrease. Notice the subtle difference between the percent of increase and the percent of decrease. To find percent of increase, you take your new amount and you subtract your original amount, and then you divide that by your original amount. Versus if you have a decrease, you take that original amount and you subtract your new amount, and then you divide by that original amount. So we'll be referencing this again, this key idea. I don't expect you to memorize this, but I would highly, highly, highly encourage you to look back at it, star it, because it'll be extremely helpful when we're trying to find a few of these problems. Okay, example 1 says the table shows the numbers of hours you spent online last weekend. What is the percent of change in your time spent online from Saturday to Sunday? Okay, on Saturday, we spent 2 hours online. And on Sunday, we spent 4.5 hours online. So the first thing we need to ask ourselves, is this an increase or a decrease situation? Are we increasing or are we decreasing? And if on Saturday it was 2 and on Sunday it was 4.5, well, 4.5 is bigger, so we're going to look for a percent of increase. We definitely increased our hours online. Okay, so going back to percent of increase, I need to take my new amount minus my original, and I need to divide that by my original. Again, I'm getting that right here. Percent of increase is new amount minus original amount divided by original. So let's fill in our numbers. The new amount is, well, the latest amount is 4.5 minus the original, or what we started at, divided by the original. So divided by 2. Notice how the original, and 2, they match up. Okay, so what is 4.5 minus 2? Well, 4.5 minus 2 would be 2.5 divided by 2. Okay, and if we divide, again, I'm okay if you're going to use calculators for this. 2.5 divided by 2 would give you, click back here, 1.25. And remember, when we want to make a decimal to a percent, we need to multiply by 100 to make it a percent, or in other words, move your decimal 2 places to the right. So that would give us 125%. percent. 1.25 as a percent. Move it 2 spots to the right. Okay. So your time spent online increased 125% from Saturday to Sunday. All right. I'll have you pause the video here to try numbers 1 and 2 here on your own and see how you do. Okay, so we're looking for percent of change here. Use your percent of change formula for increase, because you can see here we're increasing in both situations. So we take our new amount, which is 25, and we subtract our original, and then we divide by our original. So 25 minus 10 would be 15, and 15 divided by 10 would give us 1.5, which as a decimal is 150% increase. Number 2, again, I'm going to take my new amount, I'm going to subtract my original amount, I'm going to divide by my original amount. Okay, so 65 minus 57 equals 8, divided by 57 would give me 0.14. Tells me to round to the nearest tenth of a percent if necessary, so I'm going to move it 2 spots. So 14%, tenth, I'd keep it the same, so that gives me 14.0% increase. And that's not a lot of an increase, right? This is 14% isn't a whole lot, but you look here, 57 people to 65 people. We only increased by 8 people out of a total of 65. So that's not, that's not a whole lot of an increase, and we see that here. All right, let's try another example. Example 2 says, find a percent decrease. So the bar graph shows the softball players' home run totals. What was the percent of change from 2016 to 2017? So we're looking from 2016 to 2017. You'll notice in 2016 they had 28 home runs, and in 2017 they had 20. So we decreased by 8 home runs in that 1 year. So go back to your handy dandy formula here. We're using a percent decrease this time. So we take our original minus our new, and then we can divide that by our original here for example 2. Okay, let's write that down. Original minus new divided by the original. I'm doing a lot of abbreviating here, but again, this is a percent of decrease. All right, what was my original amount? Well, in 2016, it was 28 minus my new amount, 2017, it was 20, divided by that original 28. Okay, well, 28 minus 20 is 8. So that's like saying 8 out of 28 on an assignment. 8 divided by 28 would give us 0.2857. Okay, I'm going to round again to the nearest tenth. So that I'm going to round, move it 2 spots to be 28.5. And I'm going to round this 5 up to a 6 because this is higher than a 5. So that's the same as, let's see, 0.286 or 28.6%. That's a decrease. Okay, 28.6% decrease. And that makes sense. 28 down to 20 for home runs there. Okay, pause to try it here and see how you do. All right, it says in example 2, what was the percent of change from 2014 to 2015? 2014 to 2015, okay, again, we're going down in home runs. So we're using this percent of decrease formula. So the original minus the new divided by the original. So original is 18 minus the new is 10 divided by the original is 18. So that would give me 18 minus 10 is 8. And if I were to take 8 divided by 18, I would come up with 0.4 repeating. So 44.4% decrease. Big decrease there. And that makes sense. If this were, if this were 20 and the next season we had 10, well, that would we decreased by the amount of home runs we hit was half. So that's 50%, and you can tell we're close to that. So that's about right. All right, last one here talks about percent error. So a percent error is the percent that an estimated amount differs from the actual amount. Okay? And the amount of error is always positive when we're looking at percent error. Okay? So to find percent error, we take the amount of error divided by the actual amount. Okay? So here it says you fill bags with 16 ounces of homemade dog treats. The acceptable percent error when filling a bag is 5%. Okay, so say you work at a place that does this, and it's okay if you have 5% error, but anything more than that is not acceptable. So we need to look at these two bags here and see how much error that we have. Okay, well, for bag A here, the first thing I'm going to do is find the amount of error. So I know my dog bags are supposed to be 16 ounces. In bag A, I only have 15 ounces. So 16 that I'm supposed to have minus the 15 that it actually is gives me 1 ounce of error. For letter B, I'll do the same thing. I'm supposed to have 16 ounces, and the amount that's in here is 16 and a half. So 16 and a half minus 16 would give us 0.5 or half an ounce of error. You can see this one is a half of an ounce too heavy, and this one is 1 ounce too light compared to what it's supposed to be. Okay, so to find our percent error now, so percent error, we take our amount of error. So in A here, we had 1 ounce divided by the actual amount. Okay, well, our actual amount should be 16 ounces. And that'll give us our percent error. And we'll do the same for B. The amount of error, we were off half of an ounce, so 0.5, divided by the actual amount is supposed to be 16 ounces. Let's see what those two give us for percent of error. All right, for the first one, I have 1 divided by 16. Okay, so 0.0625, so 0.0625. Move it 2 spots would give me 6.25% error. And in this one, I have a half divided by 16 would give me 0.03125. Move it 2 spots. That would be 3.125% error. All right? So it says the acceptable percent error is 5%. Tell whether each bag is acceptable. So letter A here, we have 6% error, and we're only allowed 5% error. So A is not acceptable. and B is acceptable because it's under that 5% error. If we have more than 5% error, it's not acceptable. That'd be too much error. But in this case, we only have 3%. And that makes sense. This one is off by 1 ounce, and this one's only off by ½ of an ounce. So this one is closer to what the amount actually should be. Okay, so that was percent error. You might want to start this again so you can come back and look at this formula. And then we had percent increase and decrease. These two formulas are key. The new minus the original divided by the original, or the original minus the new divided by the original. Please let me know if you need more help on this. That does it for percents of increase and decrease. I'll see you guys next time.